Next, some of the terminologies in our theory of computation subject is the first one is what is an alphabet. So, alphabet is nothing but some finite, non-empty set of some symbols. So, I already told that what are the symbols means. Suppose in our English language, some of the symbols are small a, small b, small so on, some z. And coming to in our Telugu, something. These are the some of the symbols in our Telugu language. And coming to in our CSE, 0, 1 are the some of the symbols. So like this, any set of some symbols are called as alphabet. And coming to next one, what is a string? String is nothing but any sequence of symbols are called as strings. Coming to in our C language, what is a string means some collection of characters. But in our TOC subject, what is a string means any sequence of some symbols. For example, so if you take some symbols like A, B, if you take some symbols A, B, you can form infinite number of strings, just like one length string. These are the one length strings, A, B. These are the double length strings, A, B, B. These are the double length strings. And these are the triple length strings, three length strings. Like this, 4 length string, 5 length string, 6 length string, so on, infinite number of strings you can form by using some alphabets. So what is a string means? Any sequence of symbols is called as string. And in our TOC subject, there exists a null length string of length 0 is called as epsilon. So epsilon, this point is important. So what is the length of epsilon means? Epsilon contains how much length means 0. It always contains length 0. And coming to some terminologies, what is a prefix? What is a suffix? What is a substring? So these terminologies are the important. Prefix means any sequence of leading symbols. Leading symbols is called as prefix. So what is a leading symbol means? For example, if you take one string called TOC, So what are the leading symbols means? Coming from the left side, we have TOC like this. Some symbols are there. So we have some leading symbols like epsilon is common for everything. Epsilon means null and string is common for everything. First coming alphabet is T. So T is compulsory. Next after T what we have? TO. So TO is next thing. Next one is TOC. Like this, leading symbols. Leading symbols are called as prefix. So any sequence of leading symbols means we have to come from the left side. Left side like this. First T, next TO, next TOC. Like this T, TO, next TOC. Like this, leading symbols are called as prefix. Next one is what is a suffix? Suffix means any sequence of tailing symbols. Tailing symbols are nothing but we have to come from the right side. So if you take one string called TOC, coming from the right hand side. So epsilon is compulsory, you have to write. Coming to from right side, which is the alphabet first one means C is the alphabet. Next, which one means OC. Next one is TOC. Like this, you have to come from the right hand side. Those are called as suffixes. So any sequence of tailing symbols are called as suffixes. Next, what is a substring? Substring is nothing but any sequence of symbols. You can go from the left side, you can come from the right side. Like this, you are called as substrings. So if you take TOC like this, a string, epsilon is compulsory, and individual symbol is T, and the another individual symbol is O, another individual symbol is C. Like this, you can write TOC. And you can write any number of symbols like TO, OC, and TOC. Combination of like this. TO, OC, OC like this. You can write any combination. Like this, you can write any number of substrings. Now, if you give n length string, how many prefixes are possible? How many suffixes are possible? How many substrings are possible? Means if you give n length string, you can form n plus 1 prefixes. For suffixes, you can form n plus 1 suffixes. And number of substrings are sigma n plus 1. So this is the previous year gate question. So number of substrings possible by using n length string means sigma n plus 1. For example, if you take n length string 3, So how many prefixes are possible means 3 plus 1, that is equal to 4. And how many suffixes are possible means n plus 1, that is also 4. And how many substrings are possible means that is sigma 3 plus 1. So sigma 3 is nothing but 3 into 2 by 2. That is 3 plus 1 means that is also 4. Like this, you can form this number of substrings. Thank you. Next topic is finite automata. So I already told that there are 4 types of languages: type 3, type 2, type 1, type 0. I already told that type 3, type 2, type 1, type 0. So type 3 language is also called as regular language. This is accepted by finite automata. Initial classes I explained this concept. Type 3, there are 4 types of languages. This type 3 language is also called as regular language, and this regular language is accepted by automata called as finite automata. So now we coming to finite automata concept. This finite automata is classified into 2 types: finite automata without output, finite automata with output. So finite automata without output again classified into 2 types: DFA and FA. So what is the abbreviation form of DFA means? Deterministic finite automata. NFA means non-deterministic finite automata. So these are the DFA and NFA are belongs to finite automata without output. And coming to finite automata with output, this is also classified into 2 types: Moore emission and Mill emission. These are the 2 types belongs to finite automata with output. Now coming to finite automata without output, this contains 5 tuple representation. Simply DFA contains how many tuples means 5 tuples: Q, sigma, delta, S and F. So these are the 5 tuples that are present in the finite automata. So Q, sigma, delta, S, F. So what is Q means? Finite set of states. So I will explain what is Q in the example, no problem. Finally, remember that what is Q means some set of states, and what is sigma means some input symbols, and what is delta means some transition function, and what is S means starting state, what is F means final state. For example, if you take one DFA diagram like this, we have one diagram. Now we have to represent 5 tuple representation. 5 tuple means what? Q, sigma, delta, S, F. So initially I told us what is Q means. Q means some set of states. So how many states we have means we have S1 is a state, we have S2 is a state, we have S3 is a state. So what is Q means? Some set of states. Those states are S1, S2, S3. So this diagram contains how many states means 3 states that are S1, S2, S3. Now coming to sigma. What is sigma means? Some set of input alphabets. No? So input alphabets means we have 0 input and 1 input. Other than there is nothing. Only 0 and 1 inputs are there. Other than there is nothing inputs are there. So how many inputs are there means there are 0, 1. 2 inputs are there. 0, 1. Other than that there are nothing inputs are there. Now before going to transition function, what is S? S means starting state. So how we can know that among these 3 which is starting state means which has initial arrow like this, that is the starting state. So among S1, S2, S3, which is the starting state means S1 is the starting state because it contains initial arrow like this. So that is S1 is initial state. And what is F means? Final states. So among S1, S2, S3, which one is the final state means The states which are enclosed with double circles like this. Double circles like this, those are the final states. Now, is S1 is a final state means? No. Why means this is enclosed single circle only. But coming to S2 is enclosed with double circle. S3 also enclosed with double circle. That's why S2 and S3 are final states. So, Q means some set of states, sigma means some set of input symbols, S means starting state, S means starting state, and what is the F means final state. Like this, we represent the tuples, and the last one transition function. Transition function. So, how we can represent transition function means there are three states are there, S1, S2, S3, these are the three states. Now coming to S1, on state S1, if you give 0 input, on state S1, if you give 0 input, where it is going means, if you give 0 on S1 input, S1 state, it is coming to itself only. Coming to itself only, like this, it is coming to itself means that is S1 only. So, on state S1, if you give 0 input, it is coming to itself only, S1 only. Next, on S1, if you give one input, on S1, if you give one input, where it is going? S2. So it is going to S2. On S1, if you give one input like this, it is going to S2. And coming to S2, on S2, if you give 0 input, on S2, if you give 0 input like this, if you give 0 input, where it is going? S3 state. And on S2, if you give one input, it is coming to itself only. That is what was S2. And coming to S3 state, on S3, if you give 0 input, it is coming to itself only. That is nothing but S3 only. On S3, if you give one input, it is coming to itself only. Means S3 only. Like this, you have to write transition function. It is very easy, You can easy to understand that on state, if you give one input symbol like 0 or 1, where it is going? Either it is coming to itself or if it is coming to other state like this. You have to be very easy on transition function. So once you declare these 5 tuples, you have to form a table like this. It is also very easy. There are 3 states are there, S1, S2, S3. So for initial state, you have to write an arrow mark like this. For final state, you have to draw a star marks like this. Star marks like this means this indication that these are the final states. And initial arrow like this is what? Starting state. So S1 is a starting state, S2, S3 are the final states. Now we have two input symbols are 0 and 1. On S1, if you give 0 input, it is going to S1 only. That's right, you have to S1. On S1, if you give one input, where it is going? On S1, if you give one input, where it is going? S2 only. Now coming to S2, on S2 if you give 0, it is going to S3. On S2, if you give one input, it is going to S2. On S3, if you give 0, on S3 and 0, it is going S3. On S3 for 1, it is going to S3 1. Like this, by using this transition function, you can draw the table like